Okay, welcome back to part 2 of this run-through of the progress test I was using for my students as a prelude to the mocks coming up in January. We just finished electromagnetism, so I'm going through 4 topics. I'm going through electricity, which I went through in part 1, power, going through energy, and there's going to be some more energy question coming up now, and then solids, liquids and gases. That includes kinetic theory, so pressure and temperature of gases, and obviously electromagnetism questions, including a question about a dynamo. Okay, so use this video and share it with your friends if you think that it will help them. It doesn't really matter what syllabus you're preparing for. If you're my students, I'm doing this to help you do your corrections, so we don't have to use a full lesson going through corrections, and you can do it in one of your directed studies lessons if you have one. Okay. Okay, so we went through 3 questions in part 1. And here is part 2, starting with a question again on the energy topic. Okay, so the energy topic also, because it contains an electric motor, it kind of touches on electricity as well as the internal workings of electric motor you've studied in electromagnetism. Okay, so I'll use my highlighter in green. So this is the apparatus they set up. So the energy input is electrical. And the purpose of this equipment is to lift this 1 kilogram mass a set distance. So the energy output is a gain in gravitational potential energy. So the useful output is gravitational potential energy, and the energy input is the electrical value. And what they wanted to investigate is how the efficiency of an electric motor depends on the input voltage. So that will be the independent variable, okay? And the efficiency would be the calculated output variable or the dependent variable, okay? So here's the student's method. So you need to read through the student's method to understand what they're doing. So they're using a DC power supply, because remember, you just studied electric motors. You need DC power for an electric motor to make sure that it's always rotating in the same direction. They have attached a 1 kilogram mass, so that's a controlled variable. So that's a controlled variable. So you need to know your variables. So this is a skill-based question, and you don't necessarily need to revise very much, but they will always have some questions on investigation skills. Okay, so they set the voltage of the power supply in this occasion to 10 volts. So that's one of their readings. And then they switch off the power supply when the mass has been lifted through 50 centimeters, which you've got to change to meters, because when you're doing your calculation, you want to make sure that when you put it into the potential energy equation, you put it the height change in meters, not in centimeters. If you put in centimeters, you get the wrong answer, which some of my students got wrong because they didn't change the units. Okay, so you've got to use the SI units, the International System of Units. Okay, now the input energy is recorded on the joule meter, so you don't need to do anything else, except it will read off the number of joules taken up to the point where you switch off the power. It will measure how many joules the electric motor has used. Okay, and then you have to calculate, as I said, the gravitational energy that's gained. So we call it the gravitational energy store. Okay, remember that terminology, they like that in GCSE. Doesn't tend to be get used above GCSE, but that's the terminology you need for GCSE. So here's the equation again to get the output energy. So remember, this question is about efficiency, and efficiency is always the output energy divided by the input energy. Okay? So they want you to calculate the efficiency of the motor at some point in this question. So the independent variable is the voltage, as we said. So they're doing it for different voltages. Student repeats this process at different voltages. Okay. Now they want you to state how the student could improve the reliability of her investigation. Okay. So obviously she needs to do it more than once, repeat each reading. But if you just say repeat each reading, you won't get the marks. Why does she repeat each reading? To take an average value. And what kind of average is it? It's the mean average, not the mode or the median. We always use the mean average when we repeat readings. Okay? All right, so you always, when you say repeat and average and take the mean, okay? That's what is necessary to get the 1 mark. Okay, and then it says give what are the two control variables in this investigation? Well, obviously we're going to keep the mass constant at 1.0 kilograms, yeah, and the height being lifted was kept constant at 0.50 meters. Remember, meters, not centimeters. They do accept other things in the mark schemes because some students may have missed that, and they're basically a little bit too generous in my opinion. These are the correct two to mention for the 2 marks, but if you want to look at the mark scheme, it's coming up to see if you got the answer that they'll accept as alternatives. Okay. Now they want you to calculate. Show that means calculate, and prove. Show that always means calculate mathematically to prove that the gravitational potential energy store, again, that term, the gravitational potential energy store when the mass goes up by 50 centimeters is exactly 5.0 joules. So remember, you've got to change the height and put it in meters. Yeah, don't forget to do that. And there it is. You get a 1 mark for realizing you've got to do that. Then putting in 1.0. Gravity on Earth is always 10 newtons per kilogram. It'll be on the inside cover of the exam as the value that they want you to use for GCSE. And then you should really give your answer to 2 significant figures, because they've stated that they want you to show that it is 5.0. So you shouldn't leave it as 5. You need to show that the 0 is significant. The 0 is significant because that's to show how accurately you can calculate it. Okay. And then they're given all the students' results in the table. And by the way, before I forget, I listened back to my part 1, and I always tell students who are listening to listen at double speed, because when I'm talking slowly to make sure I don't make a mistake when I'm explaining it to you. But when you're listening back, you can increase the speed to 2.0, and then you can slow it down if need be. That will save you time. So my students, my advice is to listen at twice the speed. Okay. Now they want you to calculate the efficiency when the power supply was on 10 volts. They've done all the other ones in this column to 1 decimal place consistently, which is scientifically good, and they want you to work out the missing value at 10 volts. Okay, now remember, efficiency is the energy output, which is gravitational potential energy, which we just calculated as being 5.0, and divided by the energy input, which was the joule meter reading, which is 12.7. So you divide 5.0, which we just calculated above in part C, divided by 12.0, the joule meter reading, that's the electrical energy input, and that's how you get the efficiency to be 0.394. Efficiency does not have to be percentage, but then you can see that they've put a percentage here. So to get 0.394 into percentage terms, you multiply it by 100, and that becomes 39.4%. Yeah, and again, because all these figures here are to one decimal place or three significant figures, you should include three significant figures, which will be consistent with the other data provided in the table. Okay, so that's key. All right, so that's calculation of efficiency. Then they want you to plot the efficiency against the voltage. So I've put the voltage on the y-axis, and don't forget the units. But the full labeling must include percentage and voltage in volts, and then you'll get a mark for labeling your scale. And if your scale is going up in a reasonable amounts, and you've used up 50% of your graph paper, both in the y and x directions, and you've plotted it accurately, you'll get 3 marks. Yeah, and they will check if your plotting is accurate. So I've drawn my curve of best fit in red. Yeah, and there's 2 bits to it. As it's rising, the efficiency goes up. Yeah, and then it plateaus and kind of becomes a straight line here, and they're expecting you to realize that it becomes kind of constant efficiency beyond a certain value, which is around 6 volts. Can you see that? That's when the efficiency flattens out. Okay, so you don't need to go to 100% efficiency like 1 or 2 of my students did, because that will make your graph shrink, as in the data will only cover a fraction of the graph paper. You always want to zoom in, if you like, to make the spread of points as large as possible. Okay, so draw a curve of best fit. So up to 6 volts should be a smooth curve. After that, you could draw a straight line after 6.0 volts. I've drawn it just away from straight. Okay, I would give myself 2 marks, but according to the examiner, I might only get 1 mark. Okay, because they want you to draw this part as being a straight line. Okay, and then they said, using the graph, determine the minimum power supply voltage, in other words, the minimum voltage that will allow the motor to operate at the maximum efficiency, which is about 40%. So when does it reach 40%? Well, I said it's just below 6 volts. I've put it as 5.9 volts. Okay, the mark scheme will allow a range of values, and the examiner will look at your graph in case you've made a mistake, and they'll allow you to take your error forward. So error carries forward is ECF in the mark scheme. And if you've somehow made a mistake, but you've read your graph properly as to when it reaches maximum efficiency, then they may give you credit for that part of the question. Okay, so here's the mark scheme. Yeah, remember they mentioned the mean. They will allow you to use average for mean. Yeah, but I prefer my students to learn that there are 3 types of averages. Okay, just going to scroll down slowly so you can see all the parts. There's the calculation using centimeters to meters. Okay, and all the points that you can check for yourself. Okay. All right, hope that makes sense. That's 14 marks on practical skills. So very useful in preparing for your exam, for your marks. Okay, so the next question is from the latest topic that we finished, which is magnetism and electromagnetism. Yeah, and the question is about the magnetic field around a bar magnet. So I told my students that this will come up in many, many exams. Describe how an investigation to show the shape and direction of the magnetic field, okay, around a bar magnet. So it's just a single bar magnet. So I've drawn my single bar magnet. I've drawn compasses. I should have labeled this as compasses or compass. So you see, compass is put in various positions to determine the shape of the field, and the direction can be given by a compass. But if you use iron filings, you can only find the shape. So the shape could be done with iron filings, but for the direction, you must use a compass. Okay? And you want to put a compass also do the same underneath. So you have to show that there are more than one field line. Okay, so you've got to verbalize that to ensure you get the 3 marks. Okay, so I've placed multiple compasses around the bar magnet. Okay, so here, as long as you've got iron filings or compass, you'll get 1 mark. Okay, and then you should trace out the lines as shown in red in my diagram. Yeah, and these are the magnetic field lines, and the fact that you mentioned that the compass allows you to determine direction will get you a 2nd mark. Okay, and then do in further detail will get you 3rd mark. So do it at various positions around the magnet to show a variety of magnetic field lines. Yeah, both above and below the magnet. Okay, so remember this note: iron filings only allows you to determine the shape, and if you're doing iron filings, you need to say you have to tap the card. You do the iron filings on the card, you put the magnet underneath the card, you tap it so the iron filings move into position, if you like. So remember to say that you have to tap the card. So that will get you 2 marks if you use iron filings. If you use the compass method, you get 3 marks. Okay, then the question now continues, and a bar magnet is then used in a bicycle dynamo, and this rotates if you clip it onto your bicycle tire. When you cycle, you will be able to rotate the magnet, which is connected to a spindle which attaches the rotating wheel to the bar magnet inside, and as the bar magnet rotates, as the bar magnet rotates, you will see, how do I draw a rotation with my pen? As it rotates, it will induce a magnetic field in the iron core. So you're going to have induced magnetic field in the iron core. So the bar magnet rotation will create a magnetic field inside the iron core, and that because the magnetic field is constantly changing direction because of the rotation, that changing magnetic field will be felt by the coil of wire, and you'll get an induced voltage. So if you put a voltmeter here, you'll be able to measure how many volts the changing magnetic field will induce. So you're going to get an induced voltage. And then if you also, it says it goes to the lights, so the lights will feel the voltage, the light bulb will feel the voltage, and then the induced voltage will produce a current. But you've got to say, to get the full marks, or to get a full understanding, you've got to say that you have an induced voltage due to the magnetic field constantly changing, and that changing magnetic field is cutting through the conductor. So you've got to mention that the magnetic field is cutting through the coil. If there wasn't a changing field, remember the coil does not move, it's stationary. So it's only because the magnetic field is constantly changing direction that it induces the voltage and causes a current to flow. Okay? So I've explained it, how it works, and you can read it for yourself, and read it carefully. When the rotating wheel spins, the magnet spins. And the magnet spinning is what generates a changing magnetic field, where it goes north-south, north-south. Each side keeps flipping between north and south, depending on the direction of the magnet, the rotation of the magnet. Okay, and the dynamo is wired to be connected to a light on your bicycle, and it causes the light to turn on when the bicycle is being pedaled or is moving. And this whole area of physics is known as electromagnetic induction. Okay, so this is the way you need to write it. The rotating magnet induces a magnetic field in the iron core. Okay, the magnetic field is constantly changing. Why? As the magnet rotates, the north and south go opposite sides every cycle. You can't probably read my writing. This says the changing field lines cut through the wires in the coil. Now obviously it's a coil of wire, so we don't really need that bit. So it cuts through the wires in the coil, and the wires in the coil are conductors. And whenever you have field lines cutting through a conductor, the electrons feel that magnetic change, and that's what we call electromagnetic induction, which is an induced voltage. This induced voltage is across the coil. And that's induced voltage is what then causes a current to flow to the lights. But you do need to realize that it's not a current that's initially produced, it's the voltage that produces the current. So this is one of the most difficult topics in GCSE, and that's how you verbalize the 4 points. There are 5 ways to get the 4 marks. Okay? And then it says, what's a disadvantage of using a dynamo like this to power your bicycle lights? Well, it only works, light will only come on while you're pedaling, and if you're pedaling slowly, it will be a very dim light. So different ways of getting the marks. Alternatively, you say you have to do extra work pedaling against the extra friction that it creates. So you have to pedal a bit harder because there's friction between the tire and the rotating wheel, which allows you to produce light. Okay? All right, but it doesn't produce that much extra friction, so you will notice it, but it won't be stopping you from cycling. So that's a very difficult question, that you really need to learn how to write. Okay, so when you're revising, you've got to go to the levels of depth and detail to make sure your answer becomes crystal clear. You want crystal clear answers. And you can do it. You just got to learn how to verbalize your physics understanding. It comes with practice. There's the mark scheme. So iron filings or compass gets the first mark. Plotting compasses are required to show the direction, and then further detail, anything like this, will get you the 3rd mark. Okay, and there's the verbalization that I mentioned, for the most difficult questions so far. 5 ways to explain electromagnetic induction. Okay, so field lines cut by the wire or field lines cutting through the wire is a better way of putting it in this case. Okay, the changing field lines. So you want to have a changing magnetic field. If you have a changing magnetic field, it works. Final question. It's on solids, liquids, and gases again, and this time it's looking at pressure in gases, and the kinetic theory of gases is linked to temperature in Kelvin. Okay, so it's about pressure in gases. You've got an open conical flask containing air. air in the flask is heated to 85 degrees centigrade. They want you to be able to convert it into Kelvin. So you just got to add 273. And if you've got a calculator, it's a nice, easy 1 mark. If you can't calculate it correctly on a calculator, you will lose that easy mark. Now, describe how the motion of the molecules of air in the flask changes when the temperature increases. So when the temperature increases, they speed up. Yeah, 1 mark. Because temperature is proportional to the mean kinetic energy of the molecules. This sign above that means the mean kinetic energy. Mean kinetic energy, okay, is what increases. Because obviously they are all moving randomly. So to get the second mark, which I don't think many people got, you've got to mention it's the mean kinetic energy, which is directly proportional to the temperature in Kelvin. Okay? So temperature in Kelvin is directly proportional to the mean kinetic energy. Okay? So I should write here I should put mean. The mean kinetic energy of the particles will increase. Okay? Now going back to the pressure in the air of the flask does not change because it's open. It's an open flask, so when the temperature of the air increases, yeah, the molecules are moving faster, and you've got to work out what happens to the number of molecules in the flask when the temperature increases. Well, if the temperature increases, more of them will move faster, so the number of molecules inside the flask will decrease because a lot of them will just escape. Basically, the heat causes them to rise, yeah, and expand. Yeah, so if they're expanding, they're going to take up more space, so there's going to be fewer per unit volume. Fewer per unit volume. So in the space of the flask, there will now be fewer molecules. Okay? So what happens to the number of molecules, it says? So your choice is there'll be more, there'll be less, or be the same. Okay? So a lot of students didn't read the question, and heat causes expansion. Expansion means they're spread further apart, so therefore there'll be fewer left in the flask after you've heated it. Photograph 2 then continues to show if you put a boiled egg with its shell removed in the top of the flask that contained the air that was heated to, what was it, 85 degrees centigrade. So you've heated it, then you allow it to cool down, but now you put the egg here, yeah? You put the egg there, and the egg seals the flask so no more air can escape. But now it's going to cool down. So if it cools down, what's going to happen to the molecules as it cools down inside the flask? The molecules will slow down, and if they slow down, then the pressure will drop. Okay? And if the pressure drops inside there, it will suck the egg downwards because the pressure outside, yeah, the pressure outside is atmospheric pressure, 1 atmosphere. Yes? So pressure outside hasn't changed, but as you let the flask cool down, the pressure will drop, and that sucks the egg downwards. Because remember, the shell's been removed, so it's soft, and this is a good question to make you realize that there is a difference in pressure. A difference in pressure will create a downward force on the egg, okay? And the egg will change shape. So explain why the egg moves down. I've explained it. Now you've got to verbalize it. Explain why the egg moves down and then stops moving. Okay, well, that means if it stops moving, And as the egg moves down, what's going to happen? So you've got to refer to ideas about pressure in your answer. Any 4 points. Look how many ways you can get it. The air will cool. So the kinetic energy of the molecules, average kinetic energy of the molecules, will decrease. Yeah, will slow down. The pressure in the flask will decrease. The pressure outside the flask hasn't changed. The pressure difference between the outside and the inside creates a resultant force inwards or downwards on the egg, which pushes the egg down. So this is actually Newton's second law. The difference in pressure produces a force. This reduces the volume under the egg as the egg takes up the space in the flask, which will gradually then increase the pressure in the flask because the volume decrease. Egg will then stop moving when the pressure in the flask goes back to being equal to the atmospheric pressure outside the flask, because if the pressure difference is zero, the resultant force will become zero again. You'll get to a point of balanced forces. Yeah? So this is a really good question to make you think. And again, you see how you can get your clarity and your depth and detail. So if you found this test difficult, now as you do a question 13 like this is the last question in an exam paper. The real exam paper is 2 hours long, 110 marks. So you get slightly more than 1 minute a mark. Any question towards the end will be conceptually more difficult, and you need to make sure you learn how to verbalize things and really get the level of depth, detail and clarity to a high level to gain the marks. Okay, so there's the mark scheme, and you can see 4 marks for those 9 scientific points. Okay, so I hope you found that useful. That's the end of this practice exam for my students. We made it 50 marks to be able to do it in a normal lesson, and over the holiday they will do some more full paper practices which will be 2 hours long. Yeah, so the main paper is 2 hours long. If you found that useful, make sure you promote my videos with your friends, like it, share it, and subscribe if you want to watch more videos. If you go to the home page, you will find different playlists, as I mentioned to you before, so you can find other videos that will help you revise the topics that aren't covered in this paper. Okay? And there's also a membership. If students want to become members, they will get the ability to have their questions, if you ask any questions, prioritized, because obviously I may not be able to answer every single question that students come up with, and it's a way of getting something back from the hours spent in producing these videos. Okay, thanks for watching. Bye for now. Hopefully catch you in the next video.